So, when I finished high school and joined uni, I chose to pursue computer science. And as much as I knew about computer science, is that it was all about coding. That's as far as I knew. And I had been introduced to a little bit of coding in high school in Pascal, which is no longer used nowadays. A little bit of Visual Basic, which is the default language for Microsoft Access. And there was also a program called Google Computer Science for High School, which introduced us to a bit of Python. So that's all I knew about it. That's what attracted me to the field of computer science. So if you're wondering how computer science is related to AI, so computer science is basically the field. If you're looking to study the AI and how it operates and how to maybe to create your own AI or even how to utilize AI at a very deep level, that's the program to follow. You could do software engineering or many other kinds of programming and all that. So what I didn't realize at the moment is that writing code was just the surface of it. It was just the bare minimum. Like I would say 10% of it is writing code. But the bulk of it, the heaviest and the deepest part of it is just math. Pure math, all kinds of math. I got into first year and I was first slapped with calculus. Yeah. I didn't know what even a function was. Apparently, that is something I should have learned in high school, but I only remember learning calculus in high school for 2 weeks. It was only 2 weeks. We learned about differentiation and integration, and those are the only two things I remember. And there are so many ways to do them, but we only learned one way to do it. So they are functions. They were confusing me, and I was wondering, why do I need this for computer science? Then I was done with that. Then I was hit with another course called linear algebra. I was good at algebra in high school, so that wasn't a problem. But they brought me things like matrices and stuff. I knew about matrices, but they'd bring me a 9 by 9 matrix and be like multiply it with another 9 by 9 matrix, and you're going to obtain this and that. I was really wondering what the hell is going on with this program. After that, slapped with statistics. It's like, okay, where are we headed with statistics now? Statistics was one of the scariest things I've ever come across. So many theorems, so many formulas, so many functions. You even wonder who came up with all these things. Confusing at the most. I thought I was done. Then I was hit with computer logic. That's a purely math course for computer science students. It's basically how computer processes its logic. Yeah, it's also how human beings do logic, but it was mostly tailored for computer science students, and it was the most difficult thing I'd ever tried. They ask you some very stupid questions, I would say. Prove that two is an even number or something like that, or prove that the square root of two is an irrational number. Prove to me that 2 plus 2 is equals to 4. Like some stupid things like that, but they're very important in the computer process. You might take them for granted because when you type in a calculator 2 plus 2, you already know it's 4. So when you type 3,000 plus 4,000, you expect the if the calculator gives you 7,000, you accept it. But the computer does not know 2. The computer does not know the other two. The computer does not know the plus sign. The computer operates in a specific language called binary. It's zeros and ones. Basically, anything in this world, if you want to store it in a computer, you have to convert it into zeros and ones. So maybe there are to in a computer, there's usually maybe billions or trillions of zeros and ones just stored somewhere that you can make sense of and convert them to whatever you want, whatever kind of information you want to keep. So I wasn't aware of this, and the math was just getting on my nerves all this time. Then I was hit with another very deep math. It's called data structures and algorithms. You have probably heard of data structures. I don't know if you have, and you have definitely heard of algorithm. It's a very popular term on YouTube nowadays, especially among the YouTubers. They will claim, oh, the algorithm is doing this to me, or the algorithm is doing that to me, or the algorithm is against me, or the algorithm is against black people, the algorithm is against content of hate and all that. Like, there's so many accusations against the algorithm, and there are so many self-help YouTubers who give you tips and tricks on how you can conquer the algorithm, how you can take advantage of it. Although I find the advice a bit shallow most of the time. There are some who have some good advice. Although I'm not the one to judge, I also don't know the algorithm. But maybe if just a basic understanding of the algorithm, an algorithm is basically just math. That's as simply as I would put it. It's a bunch of theorems, formulas, and functions that are ordered in a very specific manner to produce a certain very specific result. That's how I put it plainly. But just for your own understanding, it's just math. It's not someone telling YouTube, like the YouTube platform, that take this video and promote it, avoid this video and all that. I know those may be baked in to the algorithm somewhere, but the algorithm doesn't know you. It doesn't know anything. It doesn't know what a video is. It doesn't know what a YouTube creator is. It doesn't know what math is or what 1 plus 1 is. It operates with zeros and ones, and it's basically trying to achieve what it's set for. And that's exactly what AI does. So if you're trying to study AI at a university level, let me say you're pursuing, you want to understand the inner workings of AI, or how to create your own AI in the future, or just how to blend in all the tools of AI at a very efficient level. What you need to study in uni is computer science, like I was doing, or you could do software engineering. I know it's packaged with different names in different universities and institutions, but it's basically the same. You need to learn a lot of math. So math is very important, and I would argue it's the most important thing in computer, because computer works with logic, and logic is purely mathematical. Whether in words, for the first time when I went to uni, I did a course in math where there was no 1 plus 1 is equals to 2. Like, it was basically math with words. Like, you describe math, like description math. That's not something I had encountered for my entire high school education. Math was arithmetic as I knew it. There were arithmetic operations. There are formulas and everything, but to boil it down, every question needed you to perform an arithmetic operation. But at university level, they are logical operations. That's something like greater than, less than, equal to, not equal to, booleans such as true and false. And they're also like just descriptive. Like, explain to me why this works. Why does the Pythagoras theorem work? Like, explain why does it work in words. That is another kind of math that I had not been introduced, but it's very critical at this level of learning. So if you really want to master AI, you need to learn math. And I think math is more important than programming. It is because uh, if I know how to write code very well, let's assume I know how to write code very well. I'm the best at it. And I was in uni. I was doing very well when coding was concerned. I was getting A's and A pluses at that time. But when it came to math, I was not doing so well. And that made me a weak computer science at that time. Because I think it's easier to teach a mathematician how to program. Like, take someone who has no experience programming, but they are an expert at math and everything. And you get this person, you teach them how to program, and they'll be more useful to you as a person in your company with AI and everything you're doing than someone who knows how to code and doesn't know mathematics. Because it's going to be very hard to teach this person logic in math. Logic is the hardest part of the math that you need to learn. With AI, you see the AI doing things like creating images for you, creating essays and articles for you. You see it creating videos for you. You see it creating music for you. But the AI doesn't know what a word is. The AI doesn't know what an image is. The AI doesn't know what a video is. The AI doesn't know what music is. Literally nothing. AI is more stupid than you. It just processes logic, like zeros and ones, numbers, arithmetic operations, and all that. So when it looks at an image, when the AI looks at an image, it sees math, like it sees numbers. That's what it sees. It's not seeing an image like you're seeing, but it knows how to put together these numbers, how to combine these formulas and functions, so that when it appears on your screen, it's not just random numbers, it's an image you can see and maybe even recognize. So images are made of pixels and all that. Those are individual cells. So the AI will study these pixels and how they mesh together, the mathematics of it all, and the formulas, the like everything. The same thing. It does the same thing with music, the tones and all that. It does the same thing with videos, and a video is very complicated because it has to be hyper aware of so many things. It also predicts the next word based on formulas and functions. So it's very important. It's very important if you're planning to make maximum use of AI, ensure that your grasp of math is strong, because that's the only way you can extract as much as possible from there. It's by understanding the math behind it. And there's something very critical to computer, and especially when it comes to algorithms and data structures. And it's a concept called graphs. I don't know whether you've heard of graphs. You probably know what a graph is from a completely layman perspective that is not computer related. It's something with an x-axis and a y-axis and some lines that move in a particular manner to show growth. And those are very important graphs. That's what they will show you. But there are things called computer graphs. And you correct me if I'm wrong. Maybe you're an expert at these. I'm not much of an expert. I'm just explaining from a layman's point of view and a bit of my experience as a student in computer science. So there is graphs, and they're basically lines, and they're lines of relationship. So there are things called nodes. A node could be a computer, it could be a server, it could be your phone, it could just be a website, it could be anything. They are nodes, and then they are connected because for these devices to talk, the computers to talk, or the phones to talk to each other. We call it talking, although it's communicating with each other. So they are nodes, they are lines, they are lines of connection, and each line represents something. It may represent a channel of it represents things. It could represent the speed of the transmission of information. It could represent the price of passing information through that, and it could represent the efficiency of communication. This is jargon, and if you're not in computer science, this may not be making sense. But they're basically lines that connect devices, websites, and all that. And each line has a cost. And as a computer science, you're trying to get information to move very fast. You're trying to move a lot of information, and you're trying to make sure you use as little space as possible. And you're trying to make sure the cost of transmitting the information is as low as possible. That's what they're doing with AI, with tokens. Just counting how much power you're using, the electrical power, the power in the memory, and all that. So those are the factors to consider. So there are things called graphs, and they give a pictorial representation of whatever I'm talking about, this phenomenon on the cost benefit analysis of a system. So AI works in the same way. These graphs, they're very important, and it's basically math. Let me see. They're represented by numbers. You may see a line labeled 4, another one labeled 5, another one labeled 20 and 30. So a programmer is supposed to determine what paths are best to use to achieve an objective that they want. So the shortest path usually is the best if you're looking for speed and efficiency and all that. But it might be expensive. It might require you to use fiber optic cables rather than normal copper cables. It might require high bandwidth rather than low bandwidth. It also determines whether you're using a wireless connection or a wired connection and all that. So it's a lot of math, I would say. A lot of math, crazy amount of math that I never expected. I dropped out of computer science because I really couldn't manage it. Not because of AI. I was not interested in AI at that time, but AI boom later on. I did a course that talks about, I'm forgetting. I think it's Moore's law, something like that, with AI and everything. So apparently, the course I took, we are talking about how AI has been cited to be the next big thing since the 1960s, and it has never been the next big thing. People say AI will take over the world in the next 5 years. It has been said since the 60s, but it's now like 60 years later, but we are still in the chatbots. And right now, I think it might have hit a pivotal moment where things have actually progressed at a faster rate than they have been progressing the other years. But we are not still at the age where AI can completely eradicate uh, human input in the program. Like the programmer still has to input measures, check for the correctness of the data, because maybe you have heard about this online. The AI is susceptible to hallucinations. It's just as I explained, like AI doesn't know what it's telling you, it doesn't know what it's showing you. If it plugs in a formula or a function, and the function gives out an answer, and the answer is correct, and then it translates that into what text or image and all that, and the image or text is wrong, it is not the AI's fault at that time. The AI just plugged in some formulas and came back with something. That something was wrong. But the computers operate on a garbage in, garbage out principles, which mean if they get the wrong input, they give you the wrong output. That's the, a little bit of it.